Welcome to the WebConference, a case study. This presentation is given asynchronously. I'm Joe Casa. I'm sorry I cannot be there with you today, but I'd like to take the opportunity to use the technology that I'm talking about to demonstrate itself. My talk today is going to discuss the WebConference, describe it, and tell you the purpose for it. Then I'm going to describe some of the prototyping experiments that were carried out over the last 2 years. I'll share some observations and some lessons learned with you. And then I'll share some specific observations in terms of how the conference affects the way requirements are dealt with and collected. And then I'll share some conclusions. A web conference in this context is basically a website with a virtual conference in it. You access the website, you find the sessions, the presentations are asynchronous, just like this one, and the discussions are also asynchronous. And there are exhibits, just like at this conference. The only difference being there, the exhibits are links to URLs, and the exhibitors can provide whatever they want to the people who get there. And so the exhibitors can do show and tell, but they don't have to travel to the conference site. Some of the advantages of the web conference are shown here. When you go to a conference, you may miss sessions because they're running in parallel. Well, here you don't. You don't have to miss a session because you can view the session at your own time and place. So travel time and costs are reduced to zero. Also, the session can be made available for a long time after the conference is over. So the knowledge remains. And there's no time limit on an asynchronous presentation. It's basically how long your listener will stay tuned to your presentation. Conversely, the asynchronous presentations can be timed. We know exactly how long this presentation is going to take before it turned on. So there's no question of running over. If the presentation will overrun, it can be edited ahead of time to make sure that it doesn't. The story starts back in 1997 when Nkosi announced that the 2001 conference would be in Sydney, Australia. It was felt that not too many employers would let their people go to Australia for a conference, and so I thought about looking for a way to boost attendance. The original concept was for a multi-site real-time conference in which the conference was taking place in Sydney, somewhere on the east coast of the United States, somewhere on the west coast of the United States, in Europe, and maybe in other places in real time, and all the sites would be linked by full duplex communications, so any presenter could be in any one of the sites. While this was going on at University College, I was faced with the problem of converting technical classes to distance delivery. These were classes in the Master of Software Engineering program. And I noticed that the conference session and the classroom lecture were almost the same in terms of presentation and discussion. So in 1998, we produced Systems Engineering to Sydney at the Nkosi conference that described the conceptual idea of the virtual hybrid web conference, and it was presented asynchronously. Although I was in the room, I didn't say a word. Actually, as the lights went down, I started to drink from a can of soda. The audience's reactions were interesting. They weren't quite sure what was going on. But then as I walked away from the podium and the voices kept going and the presentation went on, most of them smiled and settled down to listen to the presentation. And I used the same technology during the year to create 15 sessions of mini lectures in my class on software maintenance at UMUC. And if you think about it, a class like that with 14 sessions really is a single-speaker conference. The prototyping continued in 1991. The class CSMN 648 ran for the second time, and I found that I could reuse a lot of the material, and the preparation time for the class dropped tremendously from an average of 10 hours a session. First time it ran to 30 minutes a session. And most of that preparation time was taking out semester-specific information that was in the first class. I also tested synchronous communications over the internet. I used a piece of software called Phone Free that allowed me to communicate in real time with the students. And I had conversations with a student in Korea who was actually very pleased to be able to speak to his instructor for the first time. I also ran the software engineering project class, and this is the final class in the
software engineering degree program, and the students have to go through the whole life cycle from conception to delivery of a product. And one team of students actually built a WebConference prototype. Well, having the WebConference prototype in hand, I put out a call for presentations on the Nkosi Reflector, asking for people to give me a presentation that they had presented within the last 3 years at a conference with the audio added to it. And the response was underwhelming. One person responded and sent me copies of her presentations, but the audio never showed up afterwards. In April, Don Goff and I, representing UMUC, gave a presentation at the 4th Annual Intelligent Community Desktop Collaboration Conference and Exposition. This was in Virginia Beach, Virginia. The session before ours happened to be one given by Doug Vogel from City University in Hong Kong. He was in Hong Kong giving the presentation. They used several pieces of software, Microsoft's NetMeeting. We saw the talking head of Don Vogel. We saw his graphics on the screen, and the session chair advanced the graphics when Don Vogel asked him to do so. This is very much like a real-time session. The questions were typed back in text mode, and Don Vogel saw the text and answered the questions. The talking head did not really add very much extra, if anything, to the presentation. In fact, it was distracting because today's state-of-the-art in that technology means that the movement is very jerky. And there were one or two hits on the audio, but on the whole, it was an excellent presentation, and the only thing that gets you when you do a synchronous presentation over the internet is the time difference. It was the middle of the night over there. It was the middle of the afternoon over here. Here happened to be Virginia Beach, Virginia at that time. The next experiment took place in College Park, Maryland at the Web Initiative in Teaching Conference at UMUC. The conference presentation was set up ahead of time, and it used streaming audio and video over the local network from the Real Media server. The presentation was on how to create audio-enhanced PowerPoint presentations, the one you're seeing today, and actually use the technology so people would see what the result was. I was in the room, and I was able to give a meta-commentary and point out aspects of the talk that I was also giving asynchronously. The audience liked the capability to replay the session over the web at their leisure. The session is still up on my website, and since it deals with teaching how to do it, you can watch it, practice. If something is missing, you can go back to it and see it. Or you can download the presentation to your own computers and do it locally. You have an instant replay on the instructor. Again, there were one or two hits on the voices as the presentation was given, but this was another successful presentation. So it's beginning to look like we can actually do systems engineering to Sydney in an async mode. Or can we? The presentation in Nkosi, Brighton in 1999 was slightly different. Bill Mackey took the presentation over on a CD-ROM, and as session chair presented it, and while the participants were listening to it, I connected in over the internet using phone free and talked to the session chair by typing text, and then was able to take question and answers live using internet audio. And the presentation described the WebConference prototype that the students had developed at UMUC. It worked extremely well. The only bad thing about it was that it was at 6 o'clock in the morning. The first use of the WebConference took place that summer in my classes at UMUC. In CSMN 648, the software maintenance class, there were 50 students in 2 sections, and 26 students submitted asynchronous presentations. So it's not all that difficult to do, especially as the summer class was a condensed class, and the class had 2 sessions a week instead of the regular fall and spring semester of 1 session a week. I also used the technology in my systems engineering class. This was a face-to-face class, and I offered the students the option of presenting asynchronously, just in case they had stage fright and didn't want to go up in front of the class to talk. That way they could decouple the presentation and the preparation of the presentation. A couple of students chose to do it asynchronously, and I made live and recorded presentations in the class and asked the students for their feedback on it. The major comment was, If it's an asynchronous presentation, you can't interrupt it. This is exactly the same as most conference presentations when the speaker says, "I'll take questions at the end." The 5th International Conference on Asynchronous Learning Networks was held in College Park, Maryland in October of 1999. The presentation was a CD-ROM, and the discussion was supposed to have been over synchronous internet audio. This was a paper given by myself and David Kind. It was supposed to repeat the Brighton experiment, but in a different path. It failed because the IT department at University of Maryland University College couldn't connect the local area network to the session room. This is an important lesson to be learned for a multi-site conference. The lesson is it may not be the technical details, it may be the operational details that will kill you. The Systems Engineering Test and Evaluation Conference held in Adelaide, Australia in 1999 was a major test of the technology. I organized a panel on bringing the Master of Software Engineering degree online at University of Maryland University College. This mixed live CD-ROM and streaming technology from a server back in Maryland. I gave a presentation asynchronously, but being there in the room. Garth McKenzie gave a presentation on CD. He was not there either synchronously or asynchronously. And Don Goff gave a presentation using streaming technology from the server back at UMUC. We had some technical difficulties, but in the main, the presentation worked. Actually, the audience had no idea of how close it was to failure. There were some equipment problems, and then there were some user problems, but I was able to communicate with Don Goff live via text mode during the presentation and take a couple of questions from him and pass the information on to the audience. As a presentation, it worked. In terms of did everything go smoothly? No, it didn't. But the audience didn't realize it, apart from the change in the order of the presentation. So I guess that experiment was mixed results. The DECnet 99 conference in November and December was a fully online conference on the future of design computing sponsored by the International Journal of Design Computing and hosted at the University of Sydney in Australia. The conference began with a 2-week period starting on November the 16th, in which the accepted presentations were available for comment and threaded discussion in an asynchronous manner using text mode discussions. This was then followed by 4 synchronous discussion between November the 30th and December the 3rd in a virtual conference room using a Moo environment with slides and a whiteboard and communicating by typing. Those of you who are not familiar with it, Moo is an acronym for MUD, Object Orientated, where MUD itself is an acronym for Multi-User Dimensions or Dungeons, as used in a text-based virtual reality games. These were the original computer games known as Dungeons and Dragons of the early days of the personal computer era. Prototype is continuing in the year 2000. My classes in Maryland are using distance techniques for making their presentations. The software maintenance class, CSMN 648, is entirely online, and the students will be doing their presentations asynchronously. And my software project class is a hybrid class. I'm actually teaching a face-to-face class in College Park from Adelaide, Australia, with the help of Kimberly David Chung, my teaching assistant. And the students there do their presentations ahead of time before the meeting, and then at the meeting there are discussions and team working situations. So they're enhancing the class asynchronously. There's this presentation at this conference, and UniSA is going to run a distance learning conference in September, and we'll be augmenting the live forums with asynchronous presentations. Here what's going to happen is the attendees will be expected to view the presentations before they come into the forum, and the forums will be discussions. This is exactly what is happening in the MSWE 617 class. And at the CT 2000 conference, we will be meeting distance and synchronous mode, or live and distance mode presentations in the one conference. So what you're seeing here or what you're hearing here, is a forerunner. More about that later. Instead of thinking about live and online conferences, I'd like you to try and think about a continuum between synchronous and asynchronous. Synchronous means everything's happening at the same time, and that's a traditional conference. People come to a place, the action takes place, there are multi-sessions going, and you're seeing this conference, or this aspect of the conference now. Then you can move off the synchronous end of the continuum slightly into a web-enhanced conference. You're seeing conference websites go up which tell you about the conference, and sometimes the papers are published on the website. At the other end of the continuum is the completely entire asynchronous conference where nothing happens live. The presentations are up there, you download them, you view them, and you discuss them asynchronously. And there's a place for both types of conference amongst the different degrees of professional societies. In terms of systems engineering, what lesson can we learn from that experience? Well, take a look at a project timeline. At the time the project starts being developed, there is a concept. There's a concept of operations for how it's going to work. So in this instance, the original concept of operations was the multi-site synchronous real-time conference. But what actually happens during the time the project is being developed and the system development lifecycle is proceeding along the planned path, the customer's needs are changing and the customer is moving forwards in time, as showed by the horizontal arrow here, to the second triangle. So by the time the development to the original comes, that's not what the customer needed. So in 1997, the idea was for a multi-site real-time traditional conference with synchronous presentations originating at any site. By 1998, it had evolved into a multi-site traditional conference, but with asynchronous presentations and linked synchronous discussions. Notice the difference. The presentations are asynchronous in 1998. In 1999, it had evolved into a web-assisted single-site conference with asynchronous presentations and discussions. Totally online, no meetings face-to-face at all. But by 2000, it had come back to, a single-site hybrid conference with a mixture of synchronous and asynchronous presentations, synchronous and asynchronous discussions. What's going to happen in 2001? I don't know. The lessons learned from the conference perspective is synchronous teleconference is technology-driven, not application-driven. The vendors are trying to sell us technology, but nobody really knows what the requirements are. And if it's synchronous, it's equally inconvenient to all participants. Getting up at 4 o'clock in the morning to make a 6 o'clock presentation is for the birds. There's very little difference between synchronous and asynchronous presentations during the session. When the lights went down, did it matter if I was here making the presentation or not? It's only when you get to the question and answer part that you need synchronous presentations. Also, asynchronous presentations are more robust. If a speaker can't make it for some reason, the presentation is there ahead of time and can be given. There's no cancellations at the last minute. However, we also have to teach people how to communicate asynchronously. People are used to thinking synchronously. How many times does somebody leave a message on your answering machine that says, "I phoned, please call me back"? That's synchronous thinking. If they leave a message that says, "I called, I wanted to speak to you about 1, 2, 3, 4, think about A, B, C, D, and then get back to me," now we're communicating asynchronously. I bought a house when I first moved into the Washington area asynchronously. I communicated with a real estate agent asynchronously. I'd leave a message on her machine, she'd leave a message on my machine, and through that technique, we were able to purchase the house. The state-of-the-art in teleconferencing was moving as fast as the research. Every time I looked around, there was something new. And the requirements for a conference are not documented anywhere. We all seem to know what we're doing, but I couldn't find it. On objective requirements, take a look at some definitions. Webster's Dictionary defines a requirement as something required, something wanted or needed. And the IEEE definition is a conditional capability needed by a user to solve a problem or achieve an objective, or a conditional capability that must be met or possessed by a system to satisfy a contract, standard, specification, or other formally imposed document. So before we start putting together the requirements for a system, we start with a universe. The first set of requirements that we identify are those that we want. So out of the entire universe, we develop a set or a subset for requirements that we want. There's also another subset that we can identify, and those are the requirements that we don't want. For example, we want an airplane, we don't want a ship. Then there's a third area, those that we need to know that we don't care about. In other words, those that we don't forget to ask. For example, it doesn't matter what color it is. It just needs to be a color. The can decide later subset of requirements is a subset of the wanted requirements. It means we don't need to make the decision now. For example, we know that we're going to need internet audio for the web conference, but at this time we don't have to make the decision as to whether it's going to be telephone dial-up or internet audio. We'll make that decision as and when, in other words, just in time, and we'll base that decision on the technology. So if I come back to definitions, a system in this concept is a product that meets the requirements. That's the traditional definition of quality according to Phil Crosby. And so systems engineering has to be the development and modification of a system that meets the customer's requirements as stated when the project starts, as exists when the project is delivered, and is flexible enough to allow cost-effective modifications as the customer's requirements evolve over the remainder of the system's life cycle. Well, in order to do that, systems engineers would have to use magic wands. We can't actually do that, but with the right tools, techniques, and viewpoints, we can come close. What this seems to imply is that as we refine our requirements and make our design decisions, we should defer decisions until the last possible moment using the just-in-time approach. So we can take advantage of technology changes and the lowering of costs as time goes by. Conversely, this means that as we lay out the design, we have to maximize the aspects in which we don't care about to provide flexibility for implementing the change. So we have to identify those things that don't matter and we don't care about and document that and make sure that later on design decisions don't force us down a very narrow path. So instead of forecasting requirements, we have to identify the user requirements in terms of the concept operations and then backcast, figure out how we get from the concept of operations to the present state, and then move forward. So we develop the system requirements from the user requirements, prioritize them, figure out which ones we don't need to decide at this time, and there's a risk there, so you have to get it right. Identify what we don't want, identify what we don't care about, and then have a very effective change control process to make sure that as the requirements change and they move from don't need to decide, don't want, and don't care into other states, we can control that. So what can we conclude from the situation? Well, systems engineering to Sydney has been an interesting learning experience. The evolution of the concept could not have been foretold at the start of the project. And while the project is relatively simple in idea, it has illustrated many of the principles of systems and requirements engineering, and some interesting lessons have been learned from it. What's going to happen in 2001? It's a year away. We'll find out. So why not take part in the experiment and publish a paper at the same time at the CT 2000 conference in Brisbane, Australia in November? The theme of the conference is Systems Engineering and Test and Evaluation in the Changing Environment of the 21st Century. The call for papers should be out by the time this presentation is made. We're going to have a distance mode track. You too can present a paper in Australia without being there using the technology that I've demonstrated today. There's more information on the website, worldwideweb.seekforum.unisa.edu.au, or send an email to ct2000, that's the letter C, the letter T, 2000, at unisa.edu.au, University of South Australia.edu.au. So to summarize, I described the web conference, discussed some of the prototyping experiments over the last 2 years, shared some observations and lessons learned as they affect requirements in systems engineering, and then showed my conclusions. Questions and comments asynchronously via email, and thank you very much for sitting through this session.